Welcome students. This is a lecture on matrices, and in this lecture we are solving the system of linear sorry, we are solving the system of linear equations in two variables and three variables. We are solving the system of linear equations in two variables and three variables. Now, in last lecture we solved such equations using inversion method. That is, we will be given three equations, say a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. Now you have three equations in three unknowns. You have to solve them, and for this you used the method of inversion. I have taught you this in last lecture, method of inversion. In this lecture, I'm going to teach you how to solve such system of linear equation by method of reduction. I'm going to use the method of reduction. I will now, as you know here, why did we call this method, which we used in the last lecture, as method of inversion? Because we were using the inverse of a matrix to solve for x, y, z. We were using the inverse of a matrix to solve for x, y, z. Okay, here we have to get the value of x, y, z. And how did we get the value? We got the value by using the inverse of a matrix. Okay, but now why the name, the method that we are going to use here, it is method of reduction. So why the name is method of reduction, why the word reduction is being used, that also I will explain it to you. So the best way to learn this is to start solving a question. Okay, so here I will give you a question and let us solve this. The question here is, express the following equations in matrix equation form and solve them by method of reduction. So I take a question here. The equations given are x plus y plus z equals to 1, and 2x plus 3y, 2x plus 3y plus 2z equals to 2, x plus y plus 2z is 4, x plus y plus 2z equals to 4, x plus y plus 2z is 4. So we have to solve these equations for x, y, and z. Why are we solving these equations? We are solving them for the value of x, y, and z. And as I said that I will be using the method of reduction. Now listen, students, the first few steps, even in this solution, is going to be same as what we did for the inversion method. And what is that? See, we will begin our answer by writing the above equations, the above three equations can be written in matrix equation form as follows. Now what we'll do is we will write these three equations in matrix equation form. So here we will have one matrix which is a matrix of order 3 by 3, and in this we will have 1 1 1, 2 3 2, 1 1 2. Okay, this is matrix of coefficients of x, y, z. You can check here. The first equation that you have is x plus y plus z. So the coefficients are 1 1 1. So I'll write 1 1 1 here. And then the next one that I will have is, the second matrix I have is matrix of the unknowns. That is a column matrix x, y, z. And then on the right hand side I will have the matrix of RHS numbers 1 2 4. Now this matrix equation, which I write it as 1, remember this matrix equation is equivalent to these three equations. Okay, so these three equations and this matrix equation, these three equations and this matrix equations are equivalent. They are equivalent. Okay, so you write these three equations or you write this one matrix equation, it's one and the same. It's one and the same. Okay, now we move ahead and see. I write the above matrix equation is in the form AX equals to B. This matrix equation that you have written, it is in the form AX equals to B. This matrix equation is in the form AX equals to B. Remember, even in the adjoint method, this matrix equation which we had written, it was in the form AX equals to B. There what you did, you found inverse of A. That is, you found inverse of this matrix and then you pre-multiplied. Okay? And then you solve the solution. But here what we are going to do is, see, from here onwards, there will be a change in the solution. Now what we will do is check. I will convert this matrix, see, this matrix A which I have here, this matrix, which is matrix A, okay? I will transform this matrix A into an upper triangular or a lower triangular matrix. I repeat again, what I will do, I will transform this matrix, which is matrix A, I will transform this matrix into either an upper triangular matrix or a lower triangular matrix. Okay. Now, what is an upper triangular matrix? See, I will try to get zeros at these positions. Okay. If I get zeros at these positions, so you understand, students, that these zeros are below the diagonal. They are below the diagonal. Okay. So if I could transform, I repeat, when I will have transformed this matrix A like this, I will call it as an upper triangular matrix. Why? Because all the elements below the diagonal are zero, so upper triangular matrix. So this will be my first step. Okay. I will convert the matrix A into an upper triangular matrix. Okay. Can we convert it into a lower triangular matrix? Is it okay if I convert this into a lower triangular matrix? That is it okay if I go for zeros at these positions? Now what will happen? All the elements above the diagonal are zero. So this is a lower triangular matrix. Is it okay if I do this? Yes, this is also okay. Remember, students, you either have to convert that first matrix, pre-factor matrix, into a lower triangular matrix or an upper triangular matrix. Okay. So I will prefer doing it upper triangular matrix. Okay. That is, I will prefer getting zeros at these points. Okay. Next, now the thing is, what kind of transformation will I be using? Looking at this matrix, I understand that it is a pre-factor matrix. It is a pre-factor matrix. Now, since it's a pre-factor matrix, I will have to use row transformation for getting zeros here, here, and here. Okay, so I will start getting zeros. This places here. How do I get it? I will use one. See, the idea is very simple. We have done such row transformation many a times. So what I will do, I will get one here, and then using this one, I will get 0 and 0. Okay. Then I will get one here. Using this one, I will get 0. Now I don't have to go any further. You remember when we had a task of getting identity matrix at this place, then we would be doing getting 0 here, then 1 here, getting 0 and 0. So all that we don't have to do. You can say that we are doing only the first 50% of the whole procedure. We have to do only this much. Okay. So let us go ahead and start solving this. So what I will do here, student, is first I will check whether I have one at this position. Yes, see, I already have one. So what I will do, using this one, I will get 0 and 0. Okay. So I'm using method of reduction. I have to also tell you why this is known as method of reduction. For that, you will have to wait for a few minutes. Why this is known as method of reduction? So we are into the first step of method of reduction. What is that first step? I'm going to convert this matrix A in an upper triangular matrix by getting zeros below the diagonal. Okay, so here I write here R2 changes to R2 plus minus 2 R1. R2 changes to R2 plus minus 2 R1. And R3 changes to R3 plus minus 1 R1. Okay, see, I will multiply negative 2 here and add in this. So this will become 0. Multiply negative 1 here and add in this. I will get once again 0 here, right? So I have now, see, so what will this become? This will now become R1 doesn't change, it is 1, 1, 1. R2 will change. How is R2 changing? I'm multiplying negative 2 and adding here. So this is 0. Negative 2 when you multiply, this will become 1. Negative 2 when you multiply, this will become 0. Okay. Now R3 is to be changed. How is R3 changing? R3 is changing by adding minus 1 times of R1. So multiply minus 1 and add it. So this is 0. When you multiply minus 1 in here, this is also 0. When you multiply minus 1 here, this is 1. Okay. So you got this. Amazing. See here, we got the upper triangular matrix in one step only. See students, we got the upper triangle. How fortunate and how lucky we are. This is a very simple question. We got the upper triangular matrix in one step only. Okay. Now next step is what? X, Y, Z, X, Y, Z. And then what you will do? You will do the same transformation on RHS. R2 plus R2 changes to R2 plus minus to R1. R1 is same, so here you get 0. Okay. And R1 changes to R1 plus minus 1. R3 changes to R3 plus minus 1 R1. So this is 4 plus minus 1 of 1. That is 3, you guys. 4 minus 1 is 3. Okay. So this is done. Okay. Students, my first step is I could achieve the first step luckily in one go. Okay, very good. Now here, see what I have to do. I have to go for the next step. What is next step? See student, the next step is you will multiply these two matrices. The two matrices on LHS you will multiply. You will multiply this matrix with this matrix. You will multiply them. Okay. Can the multiply happen? Definitely yes. This is 3 by 3. This is 3 by 1. So the number of columns in 3 factor is 3. The number of rows in 4 factor is 3. So this will definitely happen. Now I'll multiply. So see here, when I will multiply, what? How do I multiply? First row, first column. There is no second column. So second row, first column, and third row, first column. Okay. So here I go for first row, first column. So see students, when I do that, I write here, let me write that step. I write multiplying the two matrices, on right hand side. So when I multiply, see what do I get? I will get here 1 multiplies x, so x, plus 1 multiplies y is y, plus 1 multiplies z is z. So x plus y plus z. Then I multiply the second row and first column. 0 multiplies x. There is no, see, 0 into x is 0, right? So no need to write. 0 into x is 0. Okay, let us write. 0 into x is 0 plus 1 into y is y plus 0 into z is 0. You understand? What you're getting? You're getting 0 plus y plus 0. You got 0 plus y plus 0. That's what I said. No need to write. This would be only y. This would be only y here. Okay. So what I suggest you is no need to write. Okay, leave it. Now go for the next one. What is the next one, students? Now I multiply the third row with this column. So when I multiply third row, so 0 into x is 0. plus 0 into y is 0, and 1 into z is plus z. Okay. So what you see on the RHS, you see that you are getting 103. On the RHS, you get 10. Now, students, see this. So you have two matrices, one on the left and one on the right. You have two matrices, one on the left and one on the right. Look at the left-hand matrix. The left-hand matrix you have is x plus y plus z, first element, then only y, the second element, and then only z, the third element. Okay. And this side you have 103. You have 103 on the right hand. Now, what do you notice? We notice that in the second row, this element, we are left only with y. See, there is no x, there is no z. There is no x, there is no z. And in the last one, what we saw, that there is no x, there is no y, there is only z. X and y have been removed. Now see, students, this is the reason that we call such method as a method of reduction. You have reduced the matrix. You have reduced the matrix in such a way that you obtained zeros at these positions. You have reduced the matrix in such a way that you obtained zeros at these positions. And having obtained zeros at these positions, when you are multiplying with this matrix, now here when you get zeros, try understanding, when you get zeros at this position and you multiply these two matrices, 0 into x, you saw this in the second row when you are multiplying the second row, what happened? 0 into x, x has got removed, x has got eliminated. Then in the next one, you have 0, 0. So you multiply 0 into x and 0 into y. So you get only z. So this is the reason for this method being called as reduction method, because you are reducing the coefficients to 0. And because of that, you are actually reducing the number of unknowns, number of variables. Now see, students, you have two matrices which are equal to each other. They have the same order. So in the next step, you will write, therefore, x plus y plus z is equal to 1, y equals to 0, and z equals to 3. What I will do next, I will use these two equations. Okay, I will use these two equations in I will use equation 3 and 4 in 2. So I write here using 3 and 4, using equations 3 and 4 in 2, we get what we get here, x plus 0 plus 3 equals to 1, x equals to negative 2. So see, students, we got all the values. X equals to negative 2, y equals to 0, and z equals to 3. This is the answer. Okay, I hope you all followed this. You can just have a revision of all this once again. Let us solve a word problem. Once again, by using the method of reduction. So the question here says, the total cost of 3 TV. TV is television. The total cost of 3 TV and 2 VCR. VCR is video cassette recorder. Is rupees 35,000. So 3 TVs and 2 VCRs is costing rupees 35,000. The cost of 3 TV and 2 VCR. Next. The shopkeeper wants profit of rupees 1,000 per TV and rupees 500 per VCR. So the shopkeeper first gets the television in his shop. He gets the VCRs in his shop. Now, for getting the TV and VCR in one's shop, first you have to buy from the dealers. So that is the cost price. So the shopkeeper has to pay, the shopkeeper is paying rupees 35,000 for 3 TV and 2 VCR. Now, why do you open a shop? You open a shop to earn profit. You will sell only after adding a profit to your products which you are selling. So the shopkeeper now wants profit of rupees 1,000 per TV. On one TV, he wants to earn profit of rupees 1,000. So if he is buying, say for rupees X, so how we will, so this is the cost price of TV. And what will be the selling price? The selling price will be X plus 1,000 rupees, because the shopkeeper wants 1,000 rupees as a profit. So he will add 1,000 rupees to this price and then sell in the market. So it says shopkeeper wants profit of rupees 1,000 per TV and rupees 500 per VCR. So if the VCR cost price is Y, the shopkeeper will sell one VCR in Y plus 500 rupees. So these are the cost price of TV, VCR, and here you have the selling price. The sell price or the selling price of TV and VCR. The next, it is said, the shopkeeper sells 2 TV and 1 VCR and he gets total revenue of rupees 21,500. The shopkeeper is selling 2 televisions, 2 TV and 1 VCR. That is 2 times of this. The shopkeeper is selling at the selling price. So when he is selling 2 televisions and 1 VCR, he gets a revenue of 21,500. So here we have to find, the question is, find the total cost, find the cost and the selling price of TV and VCR. Find the cost and selling price of TV and VCR. I hope you all have understood the question. Let us start solving the question. So I will begin by writing, let the cost price of TV and VCR be rupees X and rupees Y respectively. I will write, therefore, the selling price of TV equals to rupees X plus 1,000 and selling price of 1 TV and 1 VCR. Selling price of one TV, 1 VCR equals to rupees Y plus 500. See students, these are the amount for which the shopkeeper will sell. Okay. And this is the amount for which the shopkeeper is buying. The shopkeeper is buying for this amount and selling for this amount. So these are cost prices. And here you have selling prices. Okay. Now see, so there are two unknowns, X and Y. The first thing, see, what is it written? The first data says total cost of 3 TV and 2 VCR is 35,000. So I will write here. Therefore, therefore, we can write from the data. What we can write? We can write here 3x plus 2y. 3x plus 2y equals to 35,000. See, this is first equation I got. 3x plus 2y is 35,000. Why? 3 televisions and 2 VCRs. The cost price is 35,000. So the cost price of 3 television will be 3x. The cost price of 3 VCRs will be 2y. You add them and you get this. Next, they say when the shopkeeper is selling 2 televisions and 1 VCR, he is getting the revenue of 21,500. So the shopkeeper will sell 2 televisions. Now, what is the price at which the shopkeeper is selling? Here it is, x plus 1,000. So 2 into x plus 1,000 plus, he's selling 1 VCR, that is plus 1 into y plus 500, which is y plus 500, equals to, he gets 21,500. He gets 21,500. So now your second equation will be ready in a while. So here I get, therefore, let me solve this further. I get here 2x plus 2,000, 2x plus 2,000 plus y plus 500 equals to 21,500. So I get 2x plus y equals to 21,500 minus 2,500. So this is 2x plus y equals to 19,000. You got equation number 2. So see students, now we have 2 equations into unknowns, 2 variables. We have 2 equations into variables. We have to solve this by using the method of reduction. So here I will write, see the 2 equations are 3x plus 2y 35,000, 3x plus 2y equals to 35,000, and 2x plus y is 19,000. 2x plus y is 19,000. So now I write the matrix equation form. I write the above 2 equations can be written in matrix equation form as follows. So how will it be written? See, we will have 3, 2, 2, 1. 3, 2, 2, 1. You will have here x, y, and here you will have 35,000 and 19,000. Now you know what we are going to do. We will convert this into an upper triangular matrix. Okay, so see how do I go? First I get 1 here, and for getting 1 I write R1 changes to R1 plus minus 1 R2. minus 1 R2. I multiply minus 1 and add it here. Okay, so I get, see, R2 doesn't change. In this, R1 will change. So 2, 1, multiply minus 1 added, so 1. Multiply minus 1 and added, so again 1. Okay, multiply minus 1 and then x, y, and here you will get, when you multiply minus 1 and add it here, down you get 19,000, but up you get 16,000. What you will get? You will get 16,000. Now in the next step, see, using this 1, I'll get 0. I'll get 0. Using this 1, I'll get 0 here. And for that, you know the method. The transformation would be R2 changes to R2 plus minus 2 R1. And multiply minus 2 in R1 elements and add it to R2. So 1, 1, and here I'll get 0, multiplying minus 2 and adding. Multiplying minus 2 and adding, I'll get negative 1 here. No change to the post factor matrix, that will remain x and y only. And here, see, when you multiply minus 2, when you multiply minus 2 here, this will become negative 32,000. Okay, so this will remain 16 only, and down here you will get minus 13,000. This will become 32,000 negative, and when you add, so negative 32 plus 19,000 is minus 13,000. So the next step we will get is, now see, I will, now in the next step, I will multiply these two matrices. I will multiply the two matrices. Which two matrices? This matrix and this matrix will multiply. So when you multiply, I will get 1 into x is x, plus 1 into y is y. So x plus y, and here you 0 into x is 0. 0 plus minus y is minus y, equals to, see, here you got only y. Why? Because you have this element as 0. So 0 into x is 0, equals to, here you get 16,000 and minus 13,000. So now you will have, therefore, x plus y is 16,000. This is equation number 3. Minus y is minus 13,000. Equation number 4. So from 4, what you will get? See, therefore, you get y equals to 13,000. Using y in equation number 3, you will get x. What is x? X is equal to 3,000. And this is the solution. So now you will write the final answer. Therefore, the cost price of TV, you write the final answer now. Therefore, the cost price of TV and VCR are rupees 3,000. TV is 3,000. Remember, you assumed it to be X, and rupees 13,000 respectively. After that, the selling price. You will write, and the selling price of a TV and a VCR are rupees, or TV and a VCR are rupees. The selling price. How much is the profit required on a television? 1,000. So 4,000, and the profit required on VCR is 500. 13,500. This is the answer. I hope you followed it. You all can copy this. Watch this once again by rewinding it.